etc. is fine before we get started. Hello. Okay. I think I'm live now. I think I'm live now. Hello. Give me a minute. Like I will ping people on Discord and then we will get started. So yeah, like right now I'm experimenting with Twitch. So I think this stream is on Twitch right now, and once the stream ends, I will also put it on YouTube. So that's where we are. And like people in the chat, can anyone confirm if audio, video, etc. is fine before we get started? Can anyone confirm if audio, video, etc. looks fine before we get started? And I think we will start up. Yeah, I was able to solve all the problems, so I'm planning to discuss all the problems. And I think difficulty wise, G was the hardest and D was potentially harder than E here. That's what at least this AC count says. So yeah, like just 100 ACs on G and here is a dip compared to other problems here. So yeah, I will wait for a minute more and then we will get started. Hello, hello. Mic testing 1 2 3 4 5 6 7 8. Hello. Okay. Thanks. Like looks like it was audible. So I think I will get started now. So let's start with the first problem. First problem says one problem is 1 2 4 3 5. You are given an integer sequence a1, a2, a3, a4, a5 obtained by permutating these 1 2 3 4 5 values. Determine whether A can be sorted in ascending order by performing exactly one operation of swapping to adjacent elements in one. So like we have to print one, yes, if we can swap two nearby elements only once and that makes everything sorted. Otherwise the answer is no. So notoriously if array is already sorted, we should print no. There are many ways to solve this problem. One way is like you can try out each pair and see if you swap I and I plus 1, does the array become sorted. Another one thing can be like you can count the number of inversions, like number of AJ greater than AI, and that count should be 1. That is another way to solve it. Alternatively, you also know that there are just 5 numbers. So like 2, 1, 3, 4, 5, 1, 3, 2, 4, 5, 1, 2, 4, 3, 5, 1, 2, 3, 5, 4. Like you can even hardcode and check if the answer is yes only for these 4 arrays, otherwise the answer is no. And like that was the idea for the first problem. Yes, like did swap and is sorted. Yeah, like that was my idea too. Like my idea is like take the arrays input. If AI is not equal to I, then swap I and I plus 1, count plus plus, and just break them. If the count is not equal, means the array was already sorted, print no. Otherwise, if the array is now sorted, print yes, and that's the solution. So essentially, that's the idea for this problem. Any questions, anyone, before we move to the next problem? So this was the idea, and I think I will move to the next problem then. Next problem is geometric sequence. You are given length and sequence a1 to an of positive integer. Determine whether a is a geometric progression or not. Like generally, like arithmetic progressions look like this. Like they have a fixed first number a and some common ratio r, and then generally the sequence looks like this: a multiplied by r, a multiplied by r square, and so on. One idea to notice is like probably the nearby consecutive numbers are ARI plus 1 and ARI plus 2. So you can potentially notice like for any nearby number, like BI square would be equal to BI minus 1 into BI plus 1. You can use this check to check if numbers are equal or not. Like take a number, square it, and product of nearby two numbers should be equal to that square. That is one way to do it. You can also try to find the first term would be like you can also look at the common differences of each number, like basically AI by AI minus 1, maintain it as a fraction, and then check like there should be only one distinct value of these fractions here. So like these were two ways to solve this problem. So like in the contest I ended up picking that common ratio approach. Like the idea was like you look at each nearby element, divide them by GCD, and whatever number remains would be the fraction of common ratio. That was one way to do it. And then like number of distinct fractions should be only one. Another way to do it is like probably start with AI1. AI star AI is not equal to AI minus 1 into AI plus 1. Then the result is false. So that can be another way to solve this problem. Any questions, anyone, before we move to the next problem? So like this was the idea. Yes, this was problem B. Any questions, anyone, before we move to problem C? Okay, problem C is paint to make a rectangle. Like here you are given a grid of H rows and W columns. Let Ij denote the cell at ith row from the top and column J from the left. The state of grid is represented by H strings, each of length W as follows. If the character is hash, then that cell is painted black. If the character is dot, that cell is painted white. If the character is question mark, then we are yet to paint this cell. Takashi wants to paint each not yet painted cell white or black so that all the black cells forms a rectangle. More precisely, he wants there to exist a quadruple of integers a, b, c, d, like a and b are between 1 and h, c and d are between 1 and w. For each cell, which is black if and only if like that I is between a and b and j is between c and d. Otherwise, the cell is right. Determine if this is possible or not. Let's probably look at the first example and see what is the problem statement asking us to do. Mhm. Okay, my whiteboard is here. Okay, essentially, like let's look at the first example here. Like the first example looks like this. We have a grid. Like this cell is black. I don't think I let's paint cells blue instead of black. These cells are white, and we are yet to paint anything here. Let's just extend it to have one more. Mhm. This is a question mark, and like this is white. Yeah, like this, I will definitely save it on my YouTube channel once this is done. I will export it there. So, like the idea was like let's try to find the minimum rectangle which can have black cells. The idea is find the minimum row where like the black cell exists and maximum row where the black cell exists. So this is the minimum row where a blue cell exists. Let's call it blue because coloring happened. Let's find the maximum row where a blue cell exists. Let's find the minimum row where a blue cell exists, and let's find the maximum row where a blue cell exists. The idea is like these four would be the corners of the rectangle which can have all the black cells. Because the condition we have is like outside the rectangle, all the cells should be white. So we are trying to find the minimum rectangle inside which we can contain all the cells. And that will happen like that's why I'm looking at the minimum row where a blue cell exists, maximum row where a blue cell exists. Because now I know that all the blue cells must reside in these intervals only. Similarly for the columns here. And then once we have figured out like what would be the minimum rectangle where a blue cell exists, then the another idea is like next thing we should check is there should be no white cell in the minimum rectangle. And essentially that's the complete solution for this problem. Like first find the minimum rectangle where a cell exists and then just check everything inside is either blue or question marks here, no white cell. Like once we have validated this, now the solution is simple. For all the question marks inside this rectangle, paint them blue, and for all the question marks outside this rectangle, paint them white, and you are done. So this was the idea. Like first take everything as input. left minimum endpoint, right, maximum endpoint x endpoint like ij, and similarly two variables for that. For all the black cells, lx denotes the minimum row, rx denotes the maximum row. Similarly, minimum column, maximum column. We start with like the grid is valid. Now for all the white cells, see if any white cell is inside the boundaries we had for the rectangle. If the answer is yes, then the cell is invalid, otherwise the cell is valid. And essentially this ends up being the solution for problem C. Any questions, anyone? I think I will now come to problem D. And yes, problem D was harder than E, I found at least. This was problem C. Any questions, anyone on problem C before we move to problem D? Yeah, I think crux of the okay, I will just give me a minute. Any questions, anyone on problem C before we move to problem D? Okay, no questions. Yeah. Problem D, like stones are. There are n bags labeled 1 to n. Bag I contains AI stones. The customer can perform the following operation any number of times, possibly 0. Choose two bags A and B and move all the stones from bag A to bag B. Find the minimum number of different values for the following after repeating the operations like XOR of B1 to Bn. It can be proven that another constraint of the problem number of possible moves is finite. Yes, like you will be able to watch this stream later, and I will definitely put it on my YouTube channel as well, so you can find it there. So right now, let's the end goal is we will end up brute forcing it, but what all optimizations we can potentially make here. Like important concerns is notice that n is up to 12 only. So the idea is there are many ways to approach this problem. One way is let's say you have v1 up to bn. In each operation, you choose a random bj and random I, comma j, where bi is not equal to 0, and bj and bi and bj both of them are not equal to 0, and you move j to I there. And let's try to look at what is the time complexity if we keep brute forcing the ideas here. And we can stop after any number of operation here. So probably you will have at let's say you have done k operations. Like in the first operation, you will have n c2 choices. Like basically you choose n ways to pick the first cell and n minus way n cells where you would be putting all the value in, and n minus one way to choose the cell from where you would be putting all the values are. Now after the first operation, on the second operation you have n minus 1 values. You again choose which cell you would be like to pour all the values in, and then you decide which cell to put all the values from, and so on. So if you notice, if you stop here, this would be the number of operations. After, if you stop here, this would be another number of operations. And if you try to figure out the values, it would be more like this: n into n minus 1 square, n minus 2 square, and so on up to 2 square into 1, something like that. And this is essentially n factorial into n minus 1 factorial, which is 12 factorial into 11 factorial. And some more values like time complexity is roughly this of this solution. And you notice like this is definitely much more than 10 to the power 10, and it will get a TLE. So like this was the first observation we had, like time complexity is definitely exponential and it leads to a TLE here. I think many of you would have figured this out. So what's the next idea we can try over here? The next idea is like, let's say we choose we will do R operations. A1 up to AN. Let's first decide like all the values that will remain zero, non-zero after this. 1, 2, 3, 4. Like basically, NCR can be the number of values that will remain non-empty once we are done with the operations we have. Then like we can basically the idea is we can first decide which places would remain non-empty, and then for all the remaining values we can just pour those cells there. And for each cell, like now there are n minus r cell which would remain empty. So for each of them we decide which cell we will put its value in. So we'll end up with this number of possible ways to have r non-empty cells. NC are the places which will remain non-empty. And for all the other places, you can put them into one of the R places we have. You can sum this up from R equal to 1 to R equal to N. This is approximately 10 to the power 8, 2 into 10 to the power 8. Looks like we are a bit, like you can try running it using a for loop or something. And that's what I found when I was running via brute force. And like the problem here is like you have to also find all the distinct possible values here. So the problem is like although you have ran a brute force tried to find 2 into 10 to the power 8, you will potentially have one log factor to ensure that you don't count every different value more than once. Any questions on this one? Like this is second one optimization, second idea. Yes, like this optimization will also exit time memory TLE. We will get a TLE here. I'm hoping it gets a TLE, but I would be surprised if it doesn't. Now I have one more idea. Let's see each element as a group. Like basically, the idea is like the way we count probably Stirling number, something like that. Let's say A1 will remain non-empty. Then among all the remaining mass, find the set which will you put. Let's like basically the idea is the extra counting in the previous cell we were doing was like let's say 1, 2, 3, 4, 5, 6. And let's say we ended up putting 2 into 5, 4 into 5, and remaining other optimizations. My idea here is like instead of choosing which place to put in, just put it in the smallest number. So if I know like one of the cell will have A2, A4, and A5, then I try to put the cells in such a way like this element remains the second number. Like in the previous observation, like we were first choosing which cell to keep in, so we were counting it multiple, like the same cell when we were trying to find it when it was in second, when it was in fourth, and when it was in fifth. So like this is potentially the repetition we have, and the idea was if we can remove this as well, then we can potentially decrease the number of possible ways even further. Like basically whatever happens with the remaining cell, if 2, 4, and 5 are at the end going to be in the same box, why not try to count it in such a way that all of these are in second box only, rather than counting by keeping all of them in second box, keeping all of them in fourth box, and keeping all of them in the fifth box. So this gives an idea. Like one brute force can potentially be like let's say first cell will definitely go somewhere, right? So let's just try to count all the subset which will be in the same bottle as first. Move them into the first, and let's pick the next smallest cell, like let's say to 1, 2, 3, 4, 5, 6, 7, 8. Let's say after we did fourth went to first, seventh went to first. Now let's try to find what all can come in second box. We will have some set again here. Let's say 3 also came into second, 6 also came into second. Now we try to look at what all can come in fourth. Let's say nothing else comes inside fourth and nothing else comes inside eighth. So like we now have groups 1, 5, 6, 2, 3, 4, and 8. And now you can probably notice like each subset is probably going to the place where like we have minimum possible cell. And then I try to count how many possible cells, like if each state, like earlier we were counting this 3 times and 3 number of ways, this as 2 number of ways. But if we try to enumerate brute force in such a way like this, if this is the combination, then this appears only once. Then like we potentially end up with 2 into 10 to the power 6 states or something like this. That was the count I tried by looking at it. So the idea remains like this. Let's maintain the group of values we have. Start with an empty vector. When you go to A1, you put it here. So now you have A1 here. For A2, you have two choices. Either you merge with one of the existing cell or you open a new box here. So either you will have A1 plus A2 as just one bottle right now, or you can have A1 and A2 as two different bottles. Like I will probably, like I can probably enumerate with the example 257. 257. These are the cells we have, right? That is, at first we start with empty box. Then we decide like 2 would be somewhere because we cannot merge it anywhere else. We will just have it 2. Now we go with 5. So the idea is either we can have 2 comma 5 or we can have just one cell 2 plus 5 which is 7. Now when we have 7, like we can have further choices. Either we can make it 2, 5, 7. Like basically 7 remains as it is. Or 7 is merged with 2 and we get 9 or 5. Or 7 is merged with 5. So 2 comma 12 it becomes. Here, like the for 7 also, like 7 can definitely go to a different cell or 7 can be merged into one cell, 14. So like we just ended up with 5 different ways for all the 3 cells. And now we can probably look at XOR of all these values, these, and print the distinct, and you can potentially use a set to find the different count here. And essentially that's what I end up with the solution over here. And number of operations, if you try to brute force it like this, it ends up being 2 into 10 to the power 5 or so. Like basically the idea is like for all the group of cells which go into one cell, put them into the one which has the smallest index. And essentially that was the idea. And it was again a recursion. Read all the cells. Like I am maintaining, like we can potentially maintain a set here. Number of distinct values. When we are done iterating all the numbers, like current cells, like we find current XOR. Otherwise, let's look at the current value. Either we can say like it would form a new group and then you put it there itself and you try it for the next index. If you do not move it into a new group, then s dot pop back and try putting it in any other different group here. The idea is if I group it in the jth box already we have, then that increases count by 1. Try again and remove it from there and keep going. So that was the idea, and this essentially passes within the time limit. Like I also have a counter to see like what is the worst case number of distinct values I can get here. And I tried printing it and it was 2 into 10 to the power 6. So like if I try for like 4 test case I had was 12 number 1 to 12. Mm-hmm. Like unordered map, like you should be a bit like this number is 4 into 10 to the power 6 or something like that. And essentially this ends up being the solution for the fourth problem. Like at the end of the day, everything is a brute force here, just that what all potential optimizations you can make. Okay, how is it better than creating all possible subsets whose union is all set? Isn't it creating all subset also exponential? Like everything is exponential here. So probably amortize you may have same time complexity with different constant factors. Like for example, if you had two sets of 5 earlier, you were counting them 10 times or something like that. And here we are not counting that. If you use unordered map set, it will pass, right? It should potentially pass, but you should be aware of like hacks for the unordered map. You won't find that on Atcoder at least, but you will definitely find those hacks on code forces. Like you will definitely get hacked if you use unordered map. So you should be potentially careful here. You can check out what do I mean over here. So this ends up being the solution I had. Like this is pretty close to the time limit we have. And like probably one way to optimize here was just to put this in a vector. Or probably one way to optimize here was than running a for loop here, you just maintain a counter with current XOR as well. And that potentially removes the time limit we have. Like it's close to 3 seconds, I believe, which is very close to the time limit we have. 3 seconds was the time limit. So one more optimization I did in the contest was to just maintain the counter of current XOR as well, so that you don't have to run a for loop at the end. Current XOR is 0. If you add a new box, your current XOR C. Otherwise, you remove like current J from the current XOR, add it to the current value, and add it to the XOR and keep going. So that essentially maintains when you reach the end state, you definitely have current XOR with you. Okay, my map solution gave really unordered map passed. Yeah, like no, like unordered map. What the way I say is it like unordered map, although it's theoretically order one, but like the constant is equivalent to order n. But at times, like unordered map can be helpful potentially, like when you have same type of number again and again. So like I think I have gotten an AC only once. Like I have solved only I have done it only once where my like map gave me TLE and unordered map gave me an AC. Like that rarely happens, but that do happens. Unordered stat is order one, but beware like you can have hash collisions there, which can lead to order and time complexities. So like that was potentially the last optimization we need on this problem. So this was the idea for problem D. Any questions, anyone, before we move to the next problem? Like to be honest, I do not have a distinct number in time complexity. What I can say is like this ends up creating 4 into 10 to the power 6 different states here. Or we can potentially take a look at sneak peek on the editorial, like what was the intended solution here. Okay, it also says this is like basically it's number of ways to divide n into number of different groups here, which it says is a Bell number, something known as Bell number, where items and groups are indistinguished from each other. Like this is potentially the number of states I am having over here. I'm not sure if there is some approximation for the Bell numbers here, but essentially that was the way here. Like everything I would say is definitely exponential here, just that how much exponential the problem statement allows you to do. So I don't think there is a formula for time complexity here at least. So this was problem D. Any questions, anyone, before we move to problem E? No, yes, like basically, I do not have a formula for time complexity here. It's just like the number of different indistinguishable set you can potentially create over here. It turns out like that is what is known as Bell number. So the time complexity is probably 12th Bell number or something like that, which will essentially be exponential as well. B of n log B of n, where B is the Bell number. Yeah, like it says amortized set will definitely give you an AC, but map web etc. cancel you. So we should try exponential solution also for questions with n. Like at times, like when we have exponential, like the reason for small n is most of the time the solution is exponential. Can you share your Mac file? Definitely, I will do it after the I'm done with discussing all the problems. Just ask me once again there. Like it's Eknerwala setup, so I can just share what all extension I am using, and I can paste those links here. So this was problem D. Any question, anyone, before we move to problem E? Like probably I will not look at the other contests. Like right now, the focus is on the stream I have. Okay, problem E is vitamin balance. There are n foods, each containing exactly one of vitamin 1, 2, and 3. Especially eating the ith food gives you AI units of vitamin VI and CI calories. Takashi can choose any subset of this n food as long as total calorie consumption does not exceed X. Find the maximum possible value of this, like the minimum intake among vitamin 1, 2, and 3. Here is one example. Like in this example, we have different vitamins, like how much calorie for eating a particular cell can give us something there. So it is let's eat first, second, third, and fifth food. It will give us 8 units of vitamin 1, 3 units of vitamin 2, and 5 units of vitamin 3, total 25 calories. We are allowed at max 25 calories. And in this case, the minimum of these three is like 3, which is vitamin 2. And it can potentially say, like, we do not need, it's impossible to get minimum 4 calories of all the 3 vitamins. And that's why the answer here is 3. Any questions on the problem statement, anyone? Like the main idea is like we have 3 different vitamins here, and for each food we know like how much count of that vitamin will get and how much calories it will give us. We cannot have more than X calories, and it asks us to find what is the minimum quantity of all the 3 vitamins we would be able to get here. So this was the problem statement, and I think the idea I had was like let's first forget about X. Try to find like let's fix one of the vitamin. Let's say second vitamin. Let's say dpj denotes maximum number of vitamin 2 I can get using at max j calories. Or probably let's just call it dp2 if that makes sense. dp2j means like we have eaten some number of foods. What is the maximum number of quantity of vitamin 2 we can get? And we have eaten at max j calories here. Then the idea would be like dp2, we start with 0, everything as 0, like the maximum quantity with any number of calories would be 0. Then we iterate on all vitamin T food. And now the idea is like I was also optimizing the space here, but the main idea is like mostly if you do not like, let's say we have a new DP. New DPJ would be DP2J only. If we don't eat this food, otherwise, if we decide to take this food and we already had spent J calories, then with J plus C calories, we can have whatever the count of vitamin D we got plus the number of vitamin D. And you potentially need a max here. And like this would overall be order C square. Because you have one array of length C, and for each J, you are trying to see if you eat this food, what would be the updated quantities, etc. there. And like one memory optimization trick was the reason I am using two-dimensional array. Otherwise, I could have introduced more variables here. Or another way to look at it is dp2 I comma j means we have processed a1 up to ai. We have eaten j calories and the maximum number of vitamin 2 we have got. If ai plus 1 is not of second vitamin type, then we do like dp2 I plus 1 j is equal to dp2 ij. This can be 1. And if you decide to eat it, then you will have dp2 I plus 1 j plus c due to this vitamin is equal to current calories of this vitamin plus dp2 ij and so on. And if this is not second vitamin, you just make you cannot have this state over here. If this is not a second vitamin type, you cannot have this state. And once for each food, you know like what is the minimum cost for each type of, like basically for each cost, you know what is the maximum number of vitamin you can get. Like you can decide, let's say you will spend ci calories on vitamin 1, c2 calories on vitamin 2, and x minus c1 minus c2 vitamin on calorie c. So you just take minimum calories we would get over here, dp1 c1 dp2 c2 and dp3 x minus c1 minus c2, and you just take this as an answer of max, and whatever maximum value you get, max of answer comma, you keep doing this over here and call it a day. So this was the solution I had for this problem. Like if you would have more vitamins here, like then also like essentially the time complexity is number of different vitamins into c square, where d is 3 here. And you can potentially also try to use binary search over here. Few people also try to do a binary search on minimum count. Like the idea is like you first compute the same dp values, and you try to figure out how many calories you need for a particular dp value, and then you try to find by summing them like the cost you required. If cost is less than equal to x, you are good. If cost is more than x, you just move further. Like basically, for example, vitamin 1 may look like this: 0 calories 0 count, 1 calorie 3 count, 2 calorie let's say 10 count, vitamin count, 4 calories let's say 11 count, 5 calories you have let's say 14 count. Now if you want to take greater than equal to 8 calories of each vitamin, you will look at it and say you will need at least 2 calorie from the first vitamin, 3 calorie and different values from them. So you can just look at their sum and see if it's less than equal to x or not. So this was the idea for problem E. Any questions, anyone, before we move to problem F? Like how to improve, like you can find my generic advices on the Discord server I have. Like there is a channel roadmap to read in 2 minutes, something like that, where you can see what my advice are. Okay, I think I will probably move to problem F in case no one in the chat has questions here. Okay, let's move to problem F. It says double sum. You are given integer sequence a1 to an of length n. For each integer pair L comma R, define f of L comma R as follows. Start with an empty black box. Write all the integers AL to AR on a blackboard in the order. Repeat the following operations until all the integers from the board are erased. Choose integers L comma R such that every integer between L and R appears at least one on the blackboard. Then erase all the numbers L comma R from the blackboard. Let f of L comma R with the minimum such operations required to erase from the blackboard, and we have to count it for all the subarrays. Let's first forget about the subarrays. Let's try to find minimum number of operations for a given array, and then we will see how to optimize it for all the subarrays. So for example, we have this array 1, 2, 3, 1, 3, 1, 4. So the idea is like you choose the consecutive pairs from 1 to 1 and remove all the occurrences of the 1, and you will have end up with 3, 4. Now you choose all the numbers between 3 and 4, and then you remove them from there. We cannot directly choose all the numbers from 1 to 4 because you see 2 is not present here. So minimum number of operations we need here is 2. Like first question I have, like, is there any other way I can define the cost function here? So here is how I look at the same problem here. So if you see, like, essentially you look at all the numbers which are present in the array. Let's put it on a number line, something like that. 1, 2, 3, 4, up to, let's say, n. Let's also put n plus 1 and 0 here. The idea is in each operation you choose some continuous set of numbers, all of which appears in the array, and you erase them in one go. Some numbers here, and so on. And essentially the number of operations required is number of minimum number of intervals like this where you can form an array. So my idea was to, like, for every interval we will have like this. There would be one maximum number in that interval, and the number just after that will not appear in the array, right? Here also, like, this is the maximum number of this interval, and number after this is not present in the array. This is the last number in this interval, and number does not appear here. So my idea is, like, for each pair j comma j plus 1, like, basically count the number of pairs number of pairs where j is in array, is in the array, and j is plus 1 is not in the array, is not in the array. Like these would be the endpoints you will have for all the intervals you will choose for this operation. So my claim was the answer is essentially like count of such different j's we have. Because if you look at here both the numbers will not be in array, so this is not counted. If you look at here and here, j is not in the array, j plus 1 is not in the array, so you are not counting this endpoint too. Here both the numbers are in the array, so this is not also counted in this array. Only this is the place which is potentially one endpoint where this element is in the array, but element after this is not in the array. So like the problem reduces to counting number of pairs like this, where present number is in the array, but the number just after it is not in the array. So any questions like how we will solve it for the complete set we have? And now if you look at your previous example as well, right? You had 1, 3 and 4. 1, 3, 1, 3, 4. 1 is in the array, 2 is not in the array. 4 is in the array, 5 is not in the array. So the answer ends up being with 2 operations we would be able to do it. Any questions, anyone? Like why does counting number of pairs where first number is in the array and number just after it is not in the array would give me the number of operations I have? Like my main essential claim is like all those pairs would essentially be the right endpoint you will choose for each operation you have. Okay, can I stream after tomorrow's lead code? I will probably not. Like I prefer sleeping that early in the morning, but I will see if I do it sometime later. So that was the idea. Now to like solve it for the all. Now we have to count the answer for all the sub arrays. And essentially the idea is like let's start with increasing AR, A1, A2, AR minus 1. Let's say we know for this like basically like my main idea is I am maintaining a lazy segmentary or segmentary. Where like I am also increasing my right endpoint. Let's say I have processed this array so far. So seg j denotes whatever count I have, like basically count of f of j comma r, like whatever endpoint I have processed so far. Let's say this is r's element. Now my idea is like when I try to append r plus 1, then what all pairs it can impact? Either like ar plus 1 and ar plus 1. Like either you can have some change in values due to this pair, because now you can see like a new pair has appeared, and basically the or you can have some changes over here, ar plus 1 minus 1 comma ar, like basically whatever my current index is. Like essentially my idea is all the values of f of j comma r, j comma r, and if I look at f of j comma r plus 1, like the difference is at max 2. In these two values the difference is at max 2. Because like there can be only two consecutive pairs that can be impacted between these two values. Like AR plus 1 is the only thing which can potentially change whether it resides in J comma R plus 1 or not. So that was the idea. So the idea was to first remove the contribution of these two pairs from all the intervals and then add it back after moving it to R plus 1 we had. And essentially that was the solution. Like you can potentially do it with segmentary, but I decided to just do it with lazy segmentary. The idea here is, let's say we have 6 here. Let's say somewhere here is 5 and somewhere here is 7. Then now for all the values here, you will do a plus 1 due to 5 present and 6 not present. And nowhere you will have 6 present, and there is no array where 6 is present and 7 is not present. Over the part here, no, essentially we do have an array like this, right? And in the part here, if you start looking at from like this, we will have 6 present and 7 not present. And essentially that's where I will be doing plus 1, minus 1, etc. Problem F. Any questions, anyone? So the idea is like I also maintain where previously each value occurs. Then my idea is like look at remove all the contributions from AR minus 1 AR, remove all the contributions of AR and AR plus 1 current index IR. Then I say like this value appears at index R, and then I add contributions due to these two pairs again. And then I end up just taking all the sum of segment from 1 to R, f of I comma R area. So whenever I have a pair C of whatever we had, then like the minimum endpoint would be the after the current value plus 1 has appeared. We do not need a pair here. Like let's look at where the current value has appeared last time. Like only after that index you will not find this value here. So from f of j comma r, if L is j is between L2 comma r, like current pair adds 1 over here. So first I undo the contribution due to the two pairs which are impacted by current number, and then I also add those back again. So if L is greater than R, then there is no such pair we have. Otherwise, I just add whatever value I wanted to add over here. Like it adds plus 1. If I want to remove that contribution, I multiply it by minus 1. If I want to keep that contribution, I multiply by plus 1. So this was problem F. Any questions, anyone? Like I'm a bit interested in what the editorial solution was. Okay, instead of counting the right endpoint, one can potentially. Okay, I think solution is potentially trying to count for each number from 1 to R, how many ranges one of them appears and how many ranges another one. That can potentially be the another solution we have. Not sure what exactly this is doing, but this was my idea here. Any questions, anyone? Then I will move to problem B, like the hardest problem for today. Yes, we can use Atcoder library in code forces and lead code as well. Like you have a video on it. Like I do have a video on how to do that too. So you can just take a look at how to install Atcoder library, and that explains how to use it on code forces and lead code. So problem G, the last problem for today. So problem G was you are given a positive integer n. For an integer sequence a1 to an of length n, define f of a as like basically it's just saying append all the numbers in the given order. So for example, 12034 becomes 12034. Now we have n different permutations of 1 to n. We have to find what all concatenating them becomes, and we have to find that some modulo this over here. So like for example, let's say if n is 3, then we can have 3 different ways here. One, two, three, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. And if I take sum of all of these numbers, I will end up with 1, 3, 3, 2. And similarly, I have to find it for more different values, like n can be up to 2 into 10 to the power 5. So this was the problem statement. Like my idea is, like let's try to count contribution of each number we are putting here. Like let's say we will have a long number, which would be equal to like sum of digits of all the numbers from 1 to n. Let's say here we have placed a d digit number. So let's try to count, and like let's say these are l different numbers, like this length is l, and let's say here we have placed k different numbers. Then the idea is whatever value we have placed, I have placed at these d digits. That value into 10 to the power l into whatever different permutations I can potentially put here is what I am trying to do. Essentially, my idea is I fix the number of digits I want to count. Where like I am putting this block and I am counting contribution due to this. Like we have n factorial numbers, right? And like once, so the idea is like if I have C1 one digit number, C2 two digit number, C3 three digit number, C4 four digit number, then like I will probably deal with, like if I'm looking at three digit number, I will potentially try to shuffle these numbers somewhere and like C3 minus 1, because like this is a three digit number where I am counting contribution due to it. And this number can be any of the three digit number over we have. So I also ended up taking sum of all the three digit number. And the idea is, let's say L1 is the number of one digit number I place here in some form. C1 minus L1 would be one digit number which I place here. L2 is the number of two digit number which I place here. C2 here and C2 minus L2 and so on. Like basically I am dividing the number I am looking at. How many one digit number appears before it? How many one digit number appears after it? How many two digit number appears before it? How many two digit number appears after it? And so on. And overall what I will end up with is, like first choose C1, CL1 number, which you want to put it on the number before it. Then L1, like the number of ways to arrange the numbers in starting. C1 minus L1, number of ways to arrange this number towards the back, into 10 to the power L1. Like this is potentially the contribution we will have over here. This multiplied by C2, L2, number of ways to put L2 numbers in the starting. L2 factorial, arrange those numbers in starting. C2 minus L2 factorial, we have number of ways to place those numbers at the end. Like notice that like I can potentially just keep it as a multiplying factor over here. And the idea was I can potentially keep it as a loop here. And one more thing I needed over here was if n is the number, mm, or like let's probably not do it this way first. Let's just keep it this for now. Like basically, I am not yet distributing those numbers here. C1 C L1 into 10 to the power L1, C2 C L2 into 100 to the power L2, and so on. C3 C L3 into 10 to the 1000 to the power L3, like all the 5-digit number etc. I have. Once I know this, I know which 1-digit number I am keeping on the left side, one number digit I am keeping on the right side. Then I can just arrange all the 1-digit number into these many ways, number of ways to arrange it. And like n minus L1 minus L2 minus L3 minus L4 minus 1 would be the number of ways to arrange the number in the end. You have already added the count, like what would be the multiplying power of 10 when you were counting numbers like this only. And the idea was like to look at it as an FFT here, like one would be adding this here. And like you are essentially have this sum like this, right? For all L1 of L2 count, all L2, L3 count, and what you need is how many vectors. You essentially need this value only. So this smells more like an FFT problem here. And I think I have ended up skipping a lot of details here, but that might be fine. Like the idea is to just give what was the main ideas I had. So like for each digit I counted, like for each number I don't, for each number I counted how many digits it has. Like max digit we can have is potentially, let's say 7. We cannot have more than that 7 digit. For each number, length is like basically we can say 2 string j dot size. Like this would be the number of digits we will have. So number of D count denotes for a particular digit how many numbers appear. Sum count denotes for that particular length what is the sum of all the numbers here. If n is 1, like then only one permutation we can have, so we print 1 and we keep going. Otherwise, for all the numbers from 1 to 7, let's just remove dith number here, like the place where we are adding contribution due to. And the idea is like if I just keep one of the number, like this would be the multiplying factor here. Like all of these looks identical. If I am looking at contribution due to the third number, then what I will essentially end up with is if I'm taking all the sum here, 3 plus 4 plus 5, which is around 12, z and a. Like that's why I mostly need the sum of all the di digit numbers here, because all the other things remain same. So now the idea is to get multiplying factor for that particular number. Now once I know like I have removed one di digit number and I want to count like what can be the multiplying factor where this number is placed. So I again look at like this current denotes how many numbers are there on the right side, like the number after it. Contribution due to 10 to the power number would already be taken care of. So I go for all the di digit number. I count how many di digit numbers are there. And I see what would be the contributing factor if I put this number on the right side. The idea is if I put j numbers on the right side, my contributing factor would be 10 to the power di to the power j would be the power factor because of like the 10th place where we have. Then it's essentially NCR into lim comma j is the number of ways to potentially play select numbers which would be on the left side or the right side. And then one FFT idea to just essentially keep a for loop on how many numbers are there on the right. And like total numbers I will have is n. So for all the numbers from 1 to n which are on left side, like whatever contributing factor I got due to 10 to the power etc for putting numbers on the left and right, multiplied by arranging numbers on the left side and arranging remaining numbers on the right side. That is essentially the contributing factor I have when I fix which digit number would be in the middle. And you can directly use the Atcoder FFT function from the Atcoder library, which is Atcoder convolution. Any questions, anyone? Like, I think I have skipped some parts here, but that's fine. Okay, if DI digit does not appear, then you should ignore it. You cannot add it there. I think these were high level ideas I had for all the problems. And I think there were two questions in the chat like, can I provide the make file I have? Here I can. This is essentially Aknawala's setup, which I am also using. So essentially, I have three things. One is this competitive companion extension. Whenever I click on plus, I get all the samples from the contest page. And this download problem is the script which is run under the hood to create all the subdirectories and all the files there. And this makefile is the makefile I'm using to run all the pieces here. So this is the three things you need. And then there was one more question like how to improve potentially. So for that you can join the Discord server I have. Like this is the Discord server link. You can potentially read the same things which I will end up reading, but those are the generic advices I have. Like the main idea is participate in all contests, try to read editorials and try to solve those problems. And like my main suggestion for beginners is to just participate in Atcoder contests. We have solved them. And then if you're looking for some standard problem on topic X, say X, you can either go refer to USACO guide, or you can try to solve CSES problem set. In the guide, like there are different sections here: bronze, silver, gold, platinum. Platinum is harder than D1. Bronze is for absolute beginner. Whatever level you have, you can pick the problem here. There are different topics here which you can probably read, where some theory is there and some practice problems are there, so you can try to solve them. So, and different levels are different. Around 200 problems are there for the silver division. Similarly, CSES has around 200 problems categorized into different problem sets, and it comes up with the CP handbook, Complete Programming Handbook book we have. So you can potentially read this book. And then you can potentially look at what I was doing when I was expert or below, what I was doing when I was targeting candidate master rating, something like that, and what I was doing when I was potentially targeting for master rating, something like that. And a pro tip is like basically to get better at X, you should do X. Like this is a quote by Unique. And I think that's all I had. Any question? Any other questions? Anyone? So like it's essentially doing the same formulas here. I think. Okay, it might be a bit different from what I was trying in the contest. And if not, then thanks everyone for joining today. And I think today I was mostly doing it on Discord. Like probably do consider subscribing or follow whatever we have on the which server we have. And I think I will also upload this script like this video on my YouTube channel. So definitely it's available. So yeah. Is being inconsistent okay? Like I was 14 and it solved up to like this definitely happens. Like you do like you can never be consistent for all the contests you have, and like it's acceptable. Like the only thing you should potentially care about is like are you consistently practicing? In practice you should be consistent. In contest you will definitely be inconsistent, and there isn't much you can do there. So like you see like my rating also varies, minus 136 then plus 153. That definitely happens. You will always have big fluctuations in your contest, and that's fine, acceptable. And like the only thing you should potentially worry about is like you should not just hold back and see like why I was able to solve only one problem there. So like everyone has those ups and downs. That's the part of the game. Any questions? Anyone else? So I think that's all I had. Thanks everyone for joining today. And here is where I will end my stream now. Bye.